Yeah, good afternoon. Good afternoon, and welcome again for the another lecture of number system, BSc first year, semester one, paper two, unit one. Hopefully for the syllabus of RTM Nagpur University. So we were almost completed all the number systems, and today we are going to see about the conversion of gray numbers and gray numbers to binary and binary to gray. So let me share my screen. So today I will just repeat what we have studied earlier and then we'll continue with that. Yeah. So I guess my screen is visible to you. My presentation is visible to you all. Yeah. So we are trying for this. So let me introduce myself. Myself, Dr. Andy Meshram, Head of Department, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. Welcomes you again for this lecture of number system, which I guess it is actually the revision of those numbers. But let us start with that. So decimal and binary numbers we have already studied. We'll just brush it up what we have studied, and these are some of the positional weights and name how we write decimal numbers. And according to that, we have converted this decimal binary numbers decimal to binary. We have made a table of it also in the last classes. So we have completed this. This is the double method to convert a decimal number to a binary. And yeah, this is some binary numbers which are being represented for the computers. So we have used that. I have told you about those things. I guess it is not visible, right? So whatever. So this was the conversion of hexadecimal to hexadecimal. We have completed all those things earlier, and these were the hexadecimal codes which are required for the keyboards of a computer. So and their corresponding decimal hex code and the character that we are expecting to come. So these are all the hex codes over there. So that is why we require hexadecimal numbers. And these are binary arithmetic. We have also studied this and negative and positive integers in which I have told you signed numbers in which I have told you that the first bit represents the sign of that particular number. So if it is 0, then it is a positive number, and if it is 1, then it is a negative number. So I have told you all the ones and twos complement. We have gone through this. We have completed all these things, converting a decimal number. Yeah, right. So we have completed all these things, positive values and negative values. And these are those complement arithmetic logical unit, ALU, which we call it for the say for performing arithmetic and logical operations. These are overflow, yeah, overflow in binary addition, then overflow in binary addition. This is what we have shown, or I guess this is what we have completed. And this is not visible actually. So let me see why it is not visible. It is, it should be, yeah, it is visible now. Yeah, it is visible to its complement. These are some of the additions. Subtraction, we have almost completed. Subtraction, this is also not being visualized. Yes. So, yeah, decimal subtraction, we have also done this. And digital codes. So, we have this binary coded decimal 8421 code, which I have told you that this is up to 0 to 9, right? So this is a decimal number 0 to 9, which are only the 10 symbols, and the BCD code representation of these numbers in 4 bits. That is, we have already developed and studied this. This is actually the 8421 code. So now, if you have this 3-bit decimal number, that is 247, so each bit has to be converted into the binary code, right? So 2 stands for 0010, 4 stands for 0100, and 7 stands for 0111. So this is how we are going to convert a particular bit, each bit into a 4-bit BCD code. We call it as 8421 code. So these are some more examples of it and their addition, respective addition that we have to perform. Right, we have completed all those things, I guess. So we won't line in this. This is another code that is 4221 code. That is, as we have studied 8421 code. that is the weightage or the value of that particular bit. So 8421 code stands for this, 4221 code is this, it's one's complement and the other. So all the numbers have all the codes have its own significance at their place. So this is another 4221 code, which I guess if you see on this, this is a 4221 code and its corresponding one's complement, right? So one's complement is also shown over there. So it is the reverse of that, that you can say. Then, yeah, below decimal 5, use the rightmost bit for representing. So this is not in our syllabus. This is what we are concerned about. So today we are going to study this. That is the gray code, right? So what is the technical difficulty of a binary coded or a 8421 BCD code? And that is in pure binary coding of or then counting from 7001. So it requires 4 bits to change simultaneously, right? So yes, just pull it down. So 4 bits to be changed simultaneously, right? So counting from 7 to 8. So earlier it was 011 and then it has to shift from 100. So it requires 4 bits to be changed simultaneously. Before that, it requires only 3 bits to be changed. So gray coding avoids this since only 1 bit changes between the subsequent numbers. So gray coding avoids this technical difficulty of changing from say 4 bits, right? So how we convert a binary number to a gray code, right? This is the most important question, and this is asked. This question is asked many a times in your say exams. So please see this. We will also try to see it on the blackboard. So these are the steps that we have to go through. So the first step is the leftmost code digit is the same as the leftmost binary code. So whatever we are having the binary number, this is a binary number 10110, and this is to be converted into a gray. So how you are going to convert that? These are the steps to follow. So this the most significant bit, that is MSB of the binary code, is taken as it is. So we are taking this as it is. Are you able to see my screen? Anybody can unmute themselves and can reply on
Yes,
that.
sir.
Thank you. So you are able to see my cursor also. So this is the that one, and this is we are calling it as the most significant bit, right? So this most significant bit is taken as it is, and it is put in the first bit of the gray code, right? So this is the first step that you have to consider, right? So what we are trying to do, this is the binary number, that is 10110, and we are trying to convert this binary number to its equivalent gray code, right? And for that, the first step is we have to take the most significant bit as it is, and it is taken as the most significant bit of the gray code, right? Add, and the second step is we need to add the most significant bit to the next bit, right? Like this. So 1 plus 0, right? So 1 plus 0 is 1, and we will be taking this as the second bit, right? Now, the addition of this should be 1 bit only. If else there is a carry, then we have to ignore that carry. We have to know we don't have to consider that carry. We are just adding this and we'll be taking 1 bit. So 1 plus 0 is 1. So we have taken that in the second. Then we are going to add the corresponding bits like this only. The next bit, first bit added to the another bit. So in the third step, again, we have to add the second bit to the third bit. So 0 plus 1 will give you 1, right? So we are taking it 1. So the number up till now is 111, right? Three things we have done. In the first step, we are taking the most significant bit as it is, right? In the second step, what we are doing, we are adding the most significant bit to its adjacent bit, and if else there is a carry, we are going to neglect it. We are taking only one bit answer of. So 1 plus 0 is 1, so we are taking it as 1. Another, add the second bit to its adjacent bit. So 0 plus 1 is again 1. So we are taking 1 as the next gray code bit. In the fourth step, if you are able to see now, we are going to add the third bit to the adjacent fourth bit. Now here we are adding 1 plus 1. So what will be the answer? The answer is 1 0, right? Means 0 with a carry 1. So what I need to tell you over here is we are going to neglect or ignore the carry, right? So we'll be ignoring this carry. So we'll take only 0 from here. So we'll neglect the carry, the result will be 0. So 1 plus 1 is 1 0. 0 will take and will neglect the carry. So the number now will become 1110, right? Same in the last stage, sorry. In the last stage, we'll add these two bits, adjacent bits. So second last bit plus the last bit. So 1 plus 0 will give you 1, right? So the total number now it comes out to be 111. So the gray code equivalent of 10110 will be 11101. Sorry, it should have, there is one more zero over here. So it is 11101. So 5 bit, right? So 1 plus 0 is 1 again. So this is the conversion of a binary to gray code, right? We'll be going through that in the on board also. So the first bit in the for the conversion of gray to binary conversion, what we need to do is again we are going to have, now we are going vice versa. Earlier what we have done, we have converted a binary number to its equivalent gray, right? Now in this case, what we are trying to do, we are converting back gray code to its binary equivalent. Now in that also, what we are supposed to do is we are going to take this MSB as it is over there, and then we are going to add this adjacent. So the result plus this bit. And again, we in this case also we are going to neglect the can. So we are going to add vertical or cross the addition. Result plus the one, right? So to come on this, so MSB is most significant bit is one. So we are pulling this one as it is. We have to add this one with the next adjacent bit of gray. So 1 plus 1 is 0. So we are taking it as 0 again. Then again in the third step, we are going to add this. 0 plus 0 is 0, right? And so on. So by that, we are going to convert this. I guess you have understood. And if you have not understood, uh, yes, we can go for say on the board. So give me a moment. Perfect. So what we were trying to do is we are trying to convert a binary number to a gray and a gray number to its binary, right? So for that, what we have to do is we have to take that number. So we'll try it again. What was that number, binary number, that we have taken for that conversion? That number was, I guess, 10. The binary number was 10110, right? The number was 10110. I'm reminding you, we are going to convert a binary number to its gray equivalent, right? Binary to gray. So binary to gray, we are going to convert, and I'm sorry. Start this. So what we are trying to do is we are going to convert a binary to gray, and for that we have taken this number 10110, right? 10110, this number we have taken. Now what we need to do, the first step that we are going to do, this is called as the MSB, that is the most significant bit. We call this as MSB, the most significant bit, and this is called as the LSB, the least significant bit, right? So the in the first step, what we are doing, we are taking this MSB at as it is. So we are taking this as it is. So it is 1 over there. So 1 we are taken like that only. Now what we'll do, we'll add this MSB with this bit, right? So 1 plus 0. So the output will be 1. And we will go on doing that. 1 plus 0 is 1. Again, what we need to do is we need to add this 0 with this 1. So 0 plus 1 is, we'll get again a 1. Now, in the next step, the third bit plus the fourth bit. So 1 plus 1 will give you 1 0, right? 1 plus 1 will give you 1 0. So we have to take 0 and we have to neglect the carry. So I'll be writing only 0 over here. Again, add 1 plus 0. So 1 plus 0 is, will give you 1, right? So this is the answer. So this number which we have got, this was the binary number that we have taken for the conversion, and this is the gray equivalent of that number, right? So this is the binary number and this is the gray equivalent of its number. Now coming back and converting back a gray number to its binary equivalent, let us try how we have done that. I have shown you that. So for that, the first step is again the same, that we have to take the MSB as it is. So we are taking this one as it is. Now in this conversion, the change is we need to add this result to this bit. So we are going to add like this. So we are adding this one to this one, right? So in this for conversion from binary to group, we were adding the adjacent. Now in this case, from conversion to gray to binary, what we have to do is we have to add the result with the next number, right? So 1 plus 1 is 0 with a carry 1. So I am writing only 0. So the result we are writing like this, right? In the second part, again add this 0 to this 1. 0 plus 1, the result is 1. Again 1 plus 0. So the result will be 1. Okay. And again 1 plus 1. The result will be 0. So if you are able to see the number 10110 is same. 10110, right? 10110. So I am using the same bit 10110. So this is how you are going to convert a binary number to gray and a gray number to its equivalent. If you have any other example on that, just share with me. We'll be trying that on the board. So if you have any number, yes, I will try this. Yeah. So if you have any number, you can unmute yourself and let me know. So we have 1 minute. Yes, anybody can give a number, a binary number, and we will try to convert. Yeah, we'll go through that. Thank you, Sanket. Just hold for a second. Yeah, so the number which is given by Sanket is, I guess, 101011, right? So the number is, the binary number is 10111. Is that right? So we have to convert this binary number to its gray equivalent. We are trying to convert this binary number to its gray equivalent 10111. So what is the first step to do that? For that, and we are calling this as a binary number. Yes, of course. So we are calling this as a binary number and we need to convert it to gray. So for that, the most significant bit is taken as it is. So I'm taking this one as it is. Add this adjacent number, the most significant bit, to its adjacent number. So we are adding this. So 1 plus 0 will give you 1, right? 1 plus 0 will give you 1. Again, add this. 0 plus 1 will give you 1. Then 1 plus 1 will give you 0 with a carry 1. So I am writing 0 over here and we are neglecting the carry. So 0 with a carry 1. And last, so 1 plus 1 will give you again 0 with a carry 1. So the number of gray is is 11100, right? The binary number was 10111. Now for conversion, what we do, The MSB, most significant bit, is taken as it is. Add the most significant bit to its adjacent. So 1 plus 0 will get 1. Add this 0 to the next adjacent bit. 0 plus 1 is 1. 1 plus 1 is 0 with a carry 1. So we are neglecting the carry. 1 plus 1 is 0 with a carry 1. Carry neglect here. 1 plus 1 is again 0 with neglecting a carry. So it is 0. Now again coming back and doing it for the from gray to binary, we have to do the same procedure. We have to take the MS bit as it is 1, but now whatever the result is, we need to add to its adjacent bit, right? So the result plus the adjacent bit of that. So 1 plus 1 is 0, 0. Again, 0 plus 1 will give you 1, and 1 plus 0 will give you 1, and 1 plus 0 will again give you 1. I guess it is understood. So the number we are getting is again the same. So both are same numbers. So 1011, 1011. So this was the binary number that we have taken for, say, example. And this is how we have converted it to gray. And this number is again a binary number. So this is an important question from the point of view of exam. And this is, I guess it is very easiest way to convert this, right? So go through that, and if you have any queries, you can ask me right now. So the class is ready for questions. If you have any questions, you can ask me on that. Do you have any questions? Yes, anybody can unmute themselves and ask, or else we can end the class over here. Will it do? Okay. I guess there are no questions. You will try this on your own. Please go for all the numbers starting from 0, 0, 0, 0, and make a table of that. 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, sorry, 0, 1, 1, 1, 1, 0, 0, 0, and 1, 0, 0, 1. Lastly, 1, 0, 1, 0. So just go up to 9. So we'll come to know what is the gray code. So convert all these 4-bit numbers to its gray equivalent. Make a table of it. This is a homework for you, and I expect from your side that you can convert this. So we are having this from 0 to 9. So convert all those numbers to its gray equivalent. I guess you have understood what I have told you today, what I have tried to teach you today. And yeah, of course, I'm going to upload this video on YouTube. But please go through my YouTube video. Thank you for listening to me, and we'll see you in the next lecture in the with the next topic. So with that, I guess this unit is complete. And if else there are any other questions, so we can do that, right? So thank you very much. Thank you, Sanket. Have a nice time. Stay home, stay safe. Uh, Stay home, stay safe. Take care. Good day. So see you soon. Hopefully tomorrow. Bye.